We've all heard it thousands of times. Modern humans originated in Africa. But just how true is that? The out of Africa theory, while widely accepted, isn't without its flaws. Over the years, new discoveries have raised questions, challenging the idea that our entire species traces back to a single migration. However, if we didn't only come from Africa, then where did we come from? How did we get here? And what can our past teach us about the future of humanity? Stay tuned as we revisit and question the very origins of our species. Before we dive in, if you haven't seen our first video on the out of Africa theory, I highly recommend watching it before you go on. It lays the groundwork for this discussion and provides essential context. Once you're caught up, come back and join us as we explore alternative origins of humanity. Although, for the most part, the out of Africa theory stands as the most prevalent answer to the question of where we came from, the theory isn't bulletproof. Sure, it's the scientific equivalent of that friend who always has their life together, solid, well-supported, and widely accepted. But even the best theories have their awkward moments, and out of Africa is no exception. Perhaps the most shocking part is the fact that even the fossils say so. Normally, you'd think if all modern humans came from a single migration out of Africa around 60,000 years ago, we'd see a nice, clean trail of bones leading out of the continent and spreading across the world. Nope. Instead, we keep finding older human-like fossils in places where they supposedly shouldn't be. Take the skulls in China that date back 200,000 years, way before the supposed big migration. And then there's the jawbone found in Israel, clocking in at a cool 180,000 years old. If humans were only supposed to leave Africa 60,000 years ago, what are these fossils doing there? After all, they can't be time travelers, right? Then there's the major problem with our DNA. See, genetic studies mostly back up the out of Africa model, but there are some weird twists. Some populations, especially in places like Asia and Australia, have tiny traces of DNA that don't match up neatly with the expected migration timeline. Scientists used to think humans had a sexual affair with Neanderthals and Denisovans, but now there are whispers of an unknown mystery ancestor lurking in our genes. Who were they? Where did they come from? And why is no one talking about this supposed missing link? But that's not all. Even our artifacts tell a different story because ancient humans apparently loved leaving behind confusing evidence. Tools and cultural artifacts in places like India and China date back way earlier than the supposed migration should allow. It's almost like finding a smartphone in a medieval castle. Either something's off with the timeline, or someone needs to explain how our ancestors were speedrunning civilization. Now, does this mean out of Africa is completely wrong? Not necessarily. But it does mean the story isn't as neat and tidy as we once thought. Maybe there were multiple migrations. Maybe different human groups interbred more than we realized. Or maybe, just maybe, our ancient ancestors were more adventurous than we give them credit for. In order to find answers, different models of our evolution were proposed, and these are the most convincing. For much of the 20th century, the dominant model explaining human origins was the out of Africa replacement model, which argued that Homo sapiens evolved in Africa and then spread out, replacing all archaic human populations without interbreeding. However, as genetic evidence mounted in the 21st century, this idea became increasingly difficult to defend. So scientists came up with the Hybridization and Assimilation Model. This model suggests that while Homo sapiens originated in Africa, they didn't simply wipe out Neanderthals and Denisovans upon encountering them in Europe and Asia. Instead, they interbred, sharing both genes and cultural practices, and ultimately, over thousands of years, the genetic signatures of these ancient human relatives became part of the modern human genome. Think of it as seasoning in a meal. Without the seasoning, the meal still remains, but the seasoning is what makes it taste unique. But how do you defend the meal and seasoning in the first place? Well, like every other theory, you find evidence, and for this model, the most compelling evidence comes from advancements in ancient DNA analyses. In 2010, sequencing of the Neanderthal genome revealed that modern non-African populations carry about 1 to 2% Neanderthal DNA. Similarly, genetic studies on Denisovan remains found in Siberia showed that some populations, particularly indigenous groups in Oceania, like Papuans, have up to 5% Denisovan DNA. These findings confirmed that interbreeding occurred between Homo sapiens and at least 2 other human species. Now here's the thing, the distribution of archaic DNA in modern populations aligns with the regions where Neanderthals and Denisovans lived. further supporting the idea that instead of being replaced outright, these groups were absorbed into the expanding Homo sapiens populations. Beyond genetics, there's evidence that cultural and technological exchanges also took place. Today, some Neanderthal sites show signs of advanced tool use, jewelry making, and even possible symbolic behaviors, traits previously thought to be exclusive to Homo sapiens. This suggests that interactions between species may not have been purely hostile, but could have included cooperation and the sharing of knowledge. Plus, there's also the fact that Neanderthals and Homo sapiens lived in overlapping territories for thousands of years, particularly in Europe and the Middle East. This prolonged contact makes it likely that some level of cultural assimilation occurred alongside genetic hybridization. So what's the big deal here? Well, the remnants of Neanderthal and Denisovan DNA in modern humans are not just historical curiosities. They have tangible effects on health, adaptation, and even behavior. Some Neanderthal genes have been linked to helping early Homo sapiens survive in new environments. Other genes have been associated with traits like skin pigmentation, hair type, and even susceptibility to certain diseases. In fact, the EPAS1 gene, which helps Tibetans survive at high altitudes, came from Denisovans, while immune system genes from Neanderthals helped modern humans fight infections. However, not all inherited traits were beneficial. Some Neanderthal genetic variants have been linked to conditions like depression, allergies, and a higher risk of certain autoimmune diseases. This suggests that while hybridization introduced genetic diversity, natural selection continued to shape which archaic genes persisted in modern populations. Ultimately, the hybridization and assimilation model reshapes our understanding of human evolution, emphasizing that Homo sapiens did not simply outcompete or exterminate archaic human species. Instead, our ancestors interbred with them, leading to a complex web of genetic and cultural exchanges. This process of hybridization and assimilation played a significant role in shaping the genetic diversity of modern humans, showing that our lineage is more intertwined with our archaic relatives than we previously thought. On a wider scope, what if we never came from Africa, but rather came into it? That would be weird, right? Well, not according to the next theory. In more ways than one, the Inter-Africa theory was the plot twist scientists never saw coming. To understand this, imagine Homo sapiens as that one friend who moves out of town only to show up 6 months later acting all mysterious, talking about their life-changing experiences. Except in this case, the life-changing experiences involved interbreeding with Neanderthals and Denisovans in Eurasia, picking up new genetic tricks, and then waltzing back into Africa like nothing ever happened. Essentially, this perspective suggests that significant evolutionary developments occurred in regions such as East and Southeast Asia, with subsequent migrations back into Africa, contributing to the genetic and cultural makeup of contemporary African populations. Here's where it gets even crazier. Scientists have found traces of non-African DNA in modern African populations. That shouldn't happen if all human ancestry started and stayed in Africa. It's like finding a pizza recipe in an ancient Chinese cookbook. It just shouldn't be there, but somehow it is. This theory quite literally flips everything we thought we knew about human migration. It rather assumes that Africa wasn't the launchpad for humanity, it was also a melting pot where returning humans brought back new genes, skills, and maybe technology from the rest of the world. Lending a hand to this theory, some African populations today carry bits of Neanderthal and Denisovan DNA. That's right, our ancestors apparently went on a world tour, hooked up with some ancient relatives, and then brought those genes back home. Even the tools and artifacts found in Africa look suspiciously similar to ones from the Middle East and Asia, suggesting that these returning humans weren't just coming back empty-handed. They were bringing new technologies, ideas, and maybe even new ways of thinking. So why did we leave and then return? Well, according to the theory, early humans left Africa due to climate shifts, resource scarcity, population pressures, and innate curiosity. They returned when conditions improved, resources became abundant, and technological advancements made survival easier. Perhaps the craziest part is there were multiple ways they could have returned. Think of it as different flight routes on the prehistoric airline map. Some likely traveled through the Levant, passing through what is now Israel and Sinai. Others may have taken the Arabian Peninsula route, moving through present-day Saudi Arabia into northeast Africa. Some could have even made their way back through the Mediterranean, hopping from Europe into North Africa. Basically, our ancestors were racking up serious frequent traveller miles. Really though, all this theory is trying to prove is that human history isn't a straight line. It's a messy, crisscrossing web of migrations, cultural exchanges, and genetic remixing. The Into Africa theory shows that Africa wasn't just a place we left. It was a place we returned to, reshaped, and evolved in again. Of course, no wild theory comes without its fair share of drama. And the Into Africa theory is no exception. If this idea were a movie, it would have scientists in heated debates, archaeologists raising eyebrows, and geneticists double-checking their data. Although that's mostly because the evidence is still patchy. While some studies have found traces of non-African DNA in modern African populations, others argue that this could be the result of later historical migrations rather than some grand prehistoric return. Then there's the dating problem. And no, not the swiping left kind. See, pinning down exactly when these return migrations happened is tricky. Genetic data suggests that non-African DNA could have entered African populations tens of thousands of years ago, but archaeology hasn't always backed it up with solid physical evidence. To make everything just confusing, some scientists just aren't buying it. The Out of Africa model has been the reigning champion for decades, and shaking that up requires serious proof. Many argue that the presence of non-African DNA in Africa doesn't necessarily mean people migrated back. It could be the result of more recent interactions through trade and movement in the past few thousand years. In other words, maybe we didn't return to Africa as much as we just kept mingling with neighbouring populations along the way. Additionally, let's not forget the missing fossils. If large groups of early humans really did return to Africa, where are their bones, their tools, their settlements? Sure, we've found some artifacts that hint at outside influences, but a few stone tools and genetic markers aren't enough to rewrite human history just yet. Until more fossils turn up with clear signs of "I just got back from a long trip," the skeptics will keep asking for more proof. So here's a question. What if, instead of humanity starting in Africa, it actually came into Africa from somewhere else? Like, let's say, Asia. Weird, right? Well, not entirely. Stay tuned to find out. The Out of Asia theory proposed that the first true humans, our Homo ancestors, originated in Asia, particularly in regions like China, Indonesia, or even India, and only later migrated to other parts of the world, including Africa. This idea was incredibly popular in the 19th and early 20th centuries, back when researchers were piecing together human evolution without the luxury of modern genetics. Why did they think this? Well, because some of the earliest hominin fossils, like the famous Peking man or Homo erectus pekinensis, found in China, were way older than any modern human remains in Africa that had been discovered at the time. To many, it made perfect sense. Ancient apes, found in Asia. Some of the earliest hominin fossils, also in Asia. So, logically, our direct ancestors must have come from there, right? But why did people believe it? Well, one of the biggest supporters of this theory was Ernst Haeckel, a German biologist who was convinced that humans evolved somewhere in Southeast Asia. His reasoning was that the discovery of gibbons and orangutans, both of which looked kind of human-like, suggested that our earliest ancestors had to come from the same region. He even speculated that the fabled missing link between apes and humans would be found in Asia, not Africa. Then in the early 20th century, researchers in China and Indonesia started digging up fossils that made people go, wait a minute, maybe Haeckel was onto something. They found Java man, a Homo erectus, and Peking man, both of which were clear evidence that some pretty advanced early humans had been walking around Asia long before modern humans appeared in Africa. If that wasn't enough, some Chinese researchers, like the famous paleontologist Wu Jinxi, pushed the idea that Homo erectus in Asia never died out but instead evolved directly into modern East Asians, meaning that modern humans might not even have African roots at all. Instead, they argued for a regional continuity model, where early human populations in Asia evolved separately from those in Africa. So where did it go wrong? Well, as much as the Out of Asia theory was popular in its heyday, it started falling apart as new discoveries emerged, and the biggest blow was genetics. With the rise of DNA analysis, researchers could now track the movement of human populations over time, and guess what? Every genetic study pointed to Africa. Our mitochondrial DNA showed a clear pattern. Modern humans had a single origin in Africa roughly 200,000 years ago and only later spread to Asia, Europe, and beyond. Then there was the fossil evidence problem. See, while Homo erectus thrived in Asia, scientists weren't finding modern human fossils in Asia that were as old as the ones in Africa. In fact, some of the oldest Homo sapiens fossils, like those from Jebel Irhoud in Morocco, which is about 300,000 years old, were showing up in Africa, not Asia. Plus, if modern humans had evolved in Asia, you'd expect to see a gradual transition from Homo erectus to Homo sapiens there. But that's not what researchers found. Instead, it looked like modern humans suddenly appeared in Asia, as if they had migrated there from somewhere else entirely. Africa. While the idea that modern humans originated in Asia is no longer widely accepted, there are still a few interesting wrinkles. For one, Homo erectus definitely dominated Asia for a long time, and some researchers still think they might have contributed small amounts of DNA to certain modern populations, especially in East Asia. There's also the issue of China's unique fossils that continue to raise questions. See, some ancient skulls in China have a mix of modern and archaic traits, making some researchers wonder whether there was some limited interbreeding between Homo erectus and modern humans. Finally, the Denisovans, our mystery cousins, came from Asia. This group of ancient humans, discovered in a cave in Siberia, contributed DNA to modern Malaysians and some East Asians, proving that Asia played a key role in human evolution. But out of Asia wasn't the only model researchers came up with, because they also looked to Europe, and the idea was a bit more compelling. Much like the out of Asia model, the out of Europe theory suggests that the first hominins, or even early humans, didn't evolve in Africa at all, but rather in Europe, particularly in regions like the Balkans, Spain, and even Greece. This challenges the long-held belief that Homo sapiens had an African origin before migrating into Europe and Asia. Instead, it flips the script, suggesting that the earliest ancestors of modern humans developed in Asia and later moved into Africa. The idea isn't entirely new. It actually dates back to the 19th and early 20th centuries, when some European scientists were convinced that Europe was the true birthplace of humanity. But why? Well, because some of the oldest human-like fossils they had at the time, like Neanderthals, were found in Europe. But as more African fossils emerged in the 20th century, the idea of an African origin gained dominance, and the out-of-Europe idea was largely abandoned. But not so completely. In recent years, a few discoveries have made scientists scratch their heads and ask, wait a second, could Europe actually have played a bigger role in human evolution than we thought? One of the biggest shocks to the Out of Africa model came in 2017, when researchers found Greikopithecus freibergi, a 7.2 million-year-old primate fossil in Greece and Bulgaria. What made it weird was that this ancient ape had dental features closer to early hominins than African apes. If that's true, it could mean that the very first steps towards humanity didn't happen in Africa at all, but in Europe. That's not all. Some fossil sites in Spain and France contain early hominid-like remains that predate even the earliest African hominins, raising even more questions. Could it be that the earliest ancestors of humans evolved in Europe and later migrated into Africa, where they eventually gave rise to Homo sapiens? Then there's the Neanderthal connection. While we now know that Neanderthals and modern humans interbred, some researchers believe that Europe may have been home to a separate evolutionary lineage of hominids that contributed more to modern humans than we previously thought. Some even argue that modern European populations carry more genetic influence from archaic European hominids than from early African Homo sapiens. By far the biggest appeal of the Out of Europe theory is that it challenges a major assumption, that all of our ancestors had to come from a single place, Africa. Instead, some researchers believe that human evolution was more complex, with multiple populations evolving in parallel, sometimes in Africa, sometimes in Europe, and even in Asia. Another key argument is that early hominins were already highly mobile, meaning that migration between Europe and Africa wasn't just possible, it was likely happening all the time. If early hominins could move back and forth, then maybe our ancestors didn't originate in one single region, but in a much larger interconnected area. So, what are the problems with this theory? As intriguing as it sounds, the Out of Europe theory runs into some major problems. First, genetics completely wrecks the idea. Like with the Out of Asia theory, studies of human DNA overwhelmingly show that modern humans can trace their ancestry back to a single African population from around 200,000 to 300,000 years ago. If humans had originated in Europe, we'd expect to see older genetic lineages outside of Africa, but we don't. Second, the fossil record still strongly favors Africa. While Drakopithecus and a few other European fossils raise interesting questions, the majority of hominin fossils, especially early Homo sapiens, are found in Africa. Finally and uniquely, climate and geography don't really support it. See, the conditions in Africa were far more stable for early human evolution, while Europe went through extreme ice ages that would have made it much harder for early hominins to thrive long term. However, is the idea completely dead? Not entirely. While modern humans almost certainly evolved in Africa, some researchers argue that Europe may have played a much bigger role in our evolutionary history than we previously thought. After all, Europe was home to Neanderthals and other ancient human relatives for hundreds of thousands of years, and we now know that modern humans interbred with these groups. So while we probably didn't start in Europe, we definitely picked up some evolutionary baggage along the way. Speaking of connectivity, the next model focuses on just that. If you thought migration stories couldn't get any more complicated, let me introduce you to the Hominin Network model, a theory so wild, it basically suggests early humans were the original social networkers. But instead of Wi-Fi, they connected through migration, interbreeding, and cultural exchange. See, this model flips the old idea of human evolution onto its head. Instead of a simple, linear progression where one species replaces another, the Hominin Network model sees human evolution as a web of interactions between different hominid groups. To understand this, you have to picture an ancient world where early humans weren't isolated, but constantly meeting, mingling, and sometimes getting a little too close for comfort. Think of it like Game of Thrones, but with more stone tools and fewer dragons. So what makes this model special? For starters, it explains why modern humans have DNA from Neanderthals, Denisovans, and possibly even other extinct hominins we haven't fully identified yet. If Homo sapiens had simply replaced all other human species, our genetic history would be a lot cleaner. Instead, our DNA is like an ancient group project where multiple species left their contributions. The strength of the Hominin Network model comes from genetics, archaeology, and climate studies, all pointing in the same direction. Fossil evidence shows that different hominin species overlapped in space and time for thousands of years, meaning they had plenty of opportunities to exchange genes, tools, and survival strategies. In fact, advances in DNA research have proven that interbreeding wasn't just a rare accident, it happened multiple times across different continents. And this, of course, affected our culture. Some researchers believe this network wasn't just about genes, but also ideas. This spread of tool-making techniques and even symbolic behavior like cave art suggests that early human groups were learning from each other. But of course, no theory is without its challenges, and like many, one of the biggest for this model is the fossil gaps. While genetics give us a clear picture of ancient interbreeding, we're still missing a lot of physical evidence. We know Homo sapiens, Neanderthals, and Denisovans mixed, but were there other hominin species in this network? Some suspect there were, but without more fossils, it's hard to say for sure. Then there's the issue of timing. The model suggests constant interactions between different groups, but was it a slow trickle of genetic mixing, or did it happen in bursts? Some scientists argue that while interbreeding did happen, it might have been too sporadic to be considered a true network. Therefore, the big question here is, if these interactions were limited to rare encounters rather than long-term connections, does that weaken the model? So while this theory is gaining traction, it still needs more evidence to fully dethrone older models. But one thing's for sure, early humans weren't just lone wanderers. Now, something important to note is that although the Hybridization and Assimilation Model and the Hominin Network Model both acknowledge interbreeding among hominin species, they both differ in scope and emphasis. The Hybridization and Assimilation Model suggests that as anatomically modern humans migrated out of Africa, they interbred with archaic populations like Neanderthals in Eurasia, incorporating genetic material from these groups into the modern human gene pool. In contrast, the Hominin Network model, also known as the braided stream model by the way, portrays human evolution as a complex web of interconnected hominin populations that frequently diverged and converged over time. This model emphasizes continuous gene flow and cultural exchanges among various hominin groups across different regions, reflecting a more intricate evolutionary process. While both models recognize interbreeding, the Hybridization and Assimilation model focuses on specific interactions between modern humans and archaic populations during their expansions out of Africa. In contrast, the Hominin Network model provides a broader perspective, considering the entire hominin lineage's evolutionary dynamics over extended periods. So what does all of this mean? Well, if anything, it proves that human evolution isn't some straightforward one-way journey. It's messy. It's complicated. It's full of unexpected twists, lost chapters, and theories that force us to rethink everything we thought we knew. Out of Africa, into Africa, hybridization, a mix of everything. The truth is, the more we dig, the more we realize our past is far from simple. Maybe our ancestors weren't just wanderers. They were pioneers, experimenters, and survivors, constantly moving, adapting, and reshaping what it means to be human. And if history has taught us anything, it's that the story of where we came from isn't finished yet. Because with every fossil, every strand of DNA, and every unexpected discovery, we're still rewriting the greatest story ever told, our own.